Welcome, Grade 7 Explorers. Take a moment and really look at the world around you. Beneath the surface of literally everything, every rustling leaf, every speeding car, even every single breath you take, there are majestic, invisible forces at play. In today's explainer, we're going to become trackers, venturing out to observe the very lifeblood of our universe. We are hunting for energy. We're going to uncover where it hides, how it moves, and how it completely transforms our world. So, grab your gear, focus your minds, and let's get you absolutely ready for that upcoming exam as we step into the wild and fascinating realm of energy.
Here is our map for today's expedition. We'll be exploring 1. The 2 states of energy, 2. Measuring energy's weight, 3. The golden rule of conservation, and 4. Energy ecosystems or systems.
All right, let's jump right into Section 1, the 2 states of energy.
Now, before we can track energy in the wild, we have to know exactly what it is. In science, energy is defined simply as the ability to do work. It's the invisible fuel that allows absolutely anything to happen. Think about it. Without energy, the universe would be completely frozen, silent, and still. Energy is the reason you can run, the reason the sun shines, and honestly, the reason you're listening to me right now. As we look out into the world, we can see that energy basically lives in 2 totally different states of existence. It's a real duality. On one side, we have potential energy. Think of this as energy that is sleeping. It's coiled up, waiting to pounce. It's stored within an object simply because of its position or its state. But on the other side, we have kinetic energy. This is energy that is wide awake. It's actively moving and alive. It is the very energy of motion itself.
Let's see if we can spot where this potential energy actually hides. These are your exam-critical habitats, so pay close attention. First up is elastic potential energy. Imagine a stretched rubber band. It's just holding all that immense potential to snap back the second you let go. Next is gravitational potential energy. Picture yourself sitting at the very top of a tall playground slide. The Earth's gravity is pulling on you, and that sheer height gives you stored energy. And finally, we have chemical potential energy. This is the silent power hiding inside flashlight batteries, the fuels we burn, and yes, even the food you eat to power your own incredible body.
But what happens when that sleeping energy finally wakes up? Well, it bursts into kinetic energy. When you forcefully kick a soccer ball, or when water plummets down our roaring waterfall, you're seeing mechanical kinetic energy in pure action. Flying a kite? You're capturing the kinetic energy of the wind, which is literally just moving air. A speeding car takes stored chemical energy in fuel and turns it into roaring kinetic energy. But here's a wild thought. Sometimes kinetic energy is completely invisible. When electric current flows through a wire, those moving particles have kinetic energy. Even the sound waves you are hearing from me right now are a form of kinetic energy traveling through the air.
So, the big takeaway here is that all forms of energy fall into one of these 2 majestic categories. Here is a categorized view to help you lock this in for your exam prep. On the potential side, waiting in silence, we have nuclear, chemical, gravitational, and elastic energy. And over on the kinetic side, actively moving and interacting, we have electrical, radiant or light energy, mechanical, sound, and thermal or heat energy. I highly recommend taking a mental snapshot of this. It is absolutely vital for your survival on exam day.
Moving right along to Section 2, measuring energy's weight. So how do we measure something invisible? Well, the magic number you need to remember is 1,000. You see, all energy is measured in tiny units called joules, represented by a capital J. But because the stored chemical potential energy in everyday things, like the food we eat, is just so massive, we need a larger scale to weigh it. Exactly 1,000 joules make up 1 kilojoule, or kJ. Whenever you check the back of a cereal box, you are actually looking at kilojoules, a measurement of the pure survival energy just waiting to be unleashed by your body.
Which brings us to Section 3, the golden rule of conservation.
Now, to really understand the unbreakable law of the universe, we first need to understand the habitat that it rules, which is the system. A system is simple 2 or more parts that work together and require energy to function. Think of it kind of like a living ecosystem where every animal and plant relies on the others. Well, in a mechanical or biological system, every single part relies on energy flowing through it to survive and operate.
And here it is, the law of conservation of energy. Please commit this to memory, Grade 7s. Energy cannot be created or destroyed. It is converted from one form to another. This literally means the total amount of energy in the universe has always been exactly the same.
We can't make it out of thin air, and there is no way to destroy it. We can only watch and wonder as it shapeshifts and changes its disguise. Now pay close attention here, because this is a classic trope that catches a lot of explorers on their exams. You absolutely must know the difference between transferring energy and transforming it. Transferring energy is just moving it from one place to another, like passing a baton in a relay race. The type of energy stays exactly the same. But transforming, or converting energy, means it changes its disguise entirely. It shifts from one form of energy into a totally different form. Keep your eyes peeled for this distinction. It's a game changer.
And that leads us to our final stop, Section 4, Energy Ecosystems, or Systems.
Let's take all this new knowledge back out into the wild. Check out this mechanical system, a simple bicycle. The whole process actually begins with the potential chemical energy quietly stored right there inside your leg muscles. When you decide to ride, that potential energy transforms into kinetic energy in your moving legs. Now watch the transfer. That kinetic energy passes to the moving pedals and finally transfers straight into the moving wheels, propelling the whole system forward. It's just a beautiful chain reaction of motion.
Next up, let's observe a thermal system, like a traditional coal stove. We start deep in the earth with ancient, potential chemical energy locked tightly inside a lump of coal. When you ignite it, it transforms completely into roaring thermal or heat energy in the burning coal. This heat energy then transfers directly to the stoveplate and finally transfers into the pot, heating it up to cook your food. It literally goes from an ancient rock to a warm meal. Incredible, right? Let's move to a totally different environment, an electrical system. Picture switching on a simple flashlight in a dark cave. It begins with chemical potential energy, just resting in the battery. But the moment you click that switch, it transforms into electrical energy, rapidly transferring through the tiny wires. And when it reaches the bulb, a magnificent transformation occurs. It erupts into radiant light energy, piercing the darkness. Here is another incredible electrical system, a simple room fan. This time, we draw electrical energy straight from the wall plug. It transfers through the wire right into the fan's motor. But right here, the electrical energy transforms into kinetic energy. The motor starts to spin, transferring that kinetic energy into the moving fan blades, which then transfer it into the moving air that cools your face. It's literally invisible electricity becoming physical wind. Now, we venture into the most intricate systems of all, biological systems. We are tracing the ultimate migration of energy through a natural food chain. It all begins millions of miles away with the radiant light energy of the sun. This light transforms into potential chemical energy inside a blade of grass. When a grasshopper eats that grass, the stored energy transfers. It transfers again when the frog eats the grasshopper, and yet again when a snake eats the frog. The energy of the sun literally flows through the veins of the natural world. And energy doesn't even respect the boundaries between systems. Watch how it jumps from a living biological system right into a mechanical one. A horse uses its stored potential chemical energy to move. This becomes kinetic energy in the moving horse. But as the horse pulls, that kinetic energy transfers across systems, right into the moving wheels, creating the kinetic energy that moves a mechanical cart. It's a perfect seamless flow from flesh to wood and iron.
We've tracked these invisible forces from stretched rubber bands all the way to the blazing sun, through bicycles, stoves, and the very food chain itself. You are now fully equipped with the knowledge of how energy hides its potential, how it moves is kinetic, and the unbreakable golden rule that governs it all. You are definitely ready for your exam. But before we wrap up this explainer, I want to leave you with a challenge. When you walk outside today, don't just look at objects. Look at the flow. Where will you observe energy transferring and transforming in your own habitat today? Keep your eyes open, explorers.